Okay guys, so I'm going to go over the 7.3 equilateral centers proof. So you guys are essentially trying to prove that if you are given an equilateral triangle and D is the incenter, meaning AD, CD, and BD are the angle bisectors, is D also the circumcenter? Okay. So what we're going to start with here is we are going to start with the fact that it is an equilateral triangle. D is the incenter, and everything that's given, right? Okay, so here we can see, we know that triangle ABC is equilateral, meaning each of these angles is 60 degrees, okay? That's just a property of an equilateral triangle. It also means that they're congruent. Next, we're going to go to the fact that because we have the angle bisectors drawn, we know that these angles here, those are all going to be congruent, not just to each other, but also to themselves. They're going to be each 30 degrees, and then they're all going to be equal to each other. So each of these angles are congruent, okay? And that's what I have listed here, is that all of those angles are congruent. Next, what you're going to do is you're going to construct these distances from D, okay? The construction must exist because it's a distance. We know that those are going to all be formed at right angles, okay? Then, because of that angle bisector theorem, which says that if point D is on the angle bisector, it must be equal distance to both of the sides of the angle. We know that each of these, GD, FD, ED, are congruent. So just to refresh, at this point, we know that all of these angles are equal, okay? All of these sides are equal, and then we also have, because it was a distance, we also have all these right angles, okay? So we have an angle, and a side for each of these 6. 1, 2, 3, 4, 5, 6 triangles. So now, using angle, side, angle, side, using angle, side, we can say each of those small triangles, those 6 small triangles, are all congruent. Do you see that? Then, for each individual side, now for this side, right, I can say that AG is equal to GC, right? Meaning this right here is the perpendicular bisector. And then I can do that same thing. I would repeat these same words. I can say that DF is the perpendicular bisector of CB, and I can say that DE is the perpendicular bisector of AB. Because we've just said that each of these lines are the perpendicular bisector of each of the sides, D is where they coincide, so D is the circumcenter because that's the definition of a circumcenter. Okay? That's it. That's the proof done. Please go ahead and watch the video again to see if you understand it. And then that's it.